Hello everyone and welcome to this training session on analysis of covariance using SPSS. In short, the analysis of covariance is also called as ANOVA analysis. Analysis covariance. So that is why we are calling this as ANOVA analysis. Probably this is one good tool which is mixing up ANOVA, which we have discussed in our earlier session, looks at the uniformity of the means, uniformity or equality of the means in the dependent variable based on one or more categorical variables. So when we use one-way ANOVA, we are grouping the data based on one categorical variable and looking at the means of some other variable across the different values of the categories. So this ANOVA model primarily blends the same ANOVA along with the regression effect for us. So because when we define the word covariance, it is nothing but the way or the extent to which two variables change together, and probably a correlation is a byproduct of covariance. So that's where we are talking about how much of a relationship exists between the two variables, and what is the strength of that relationship. So when we are doing analysis of covariance, I am extending the typical ANOVA procedure. In ANOVA, what were we doing? We were taking one dependent variable and looking at the means, or comparing the means of this dependent variable across, let's say, the various values of the independent factor. If I'm using one factor, I'm calling it as one-way ANOVA, otherwise two-way ANOVA. So I'm trying to evaluate or compare the means of the dependent variable exposed to various factors. But in an ANOVA analysis, what we do is we introduce something called as a control variable. Means it might so happen that the dependent variable which we have considered, it might be dependent on some other scale variable. It might be dependent on some other scale variable, and because of that the means are changing for different categories. So what we are doing as a part of ANOVA analysis is bringing in these scale variables, trying to understand if this has any level of dependency as a part of this scale variable, and based on that, if I neutralize the impact of this, that is what it means, adjusting the dependent variable if all the groups were equal on the control variable. This particular variable, it could be changing across the groups, and because of this is changing. So it's not, the means are directly not changing, because the other control variable is changing, we are seeing that the means are changing. So what this ANOVA analysis does for us is, if at all I remove the impact of this variable, which means if I neutralize this variable on this count, if at all the variables have this same dependent, this same value, or more or less uniform on this independent variable, what could be the impact on the average means of the dependent variable across various categories. So that is what can be tested very well using this ANOVA analysis. For our cricket example again, I'll try to create this question. Look out for the relationship between the, look out for the relationship between the runs per over based on the innings, first innings or second innings, but control it controlled by the first wicket partnership. Now what I am saying is, please observe the runs per over. What is the kind of, is there a uniformity or is there a significant difference in the runs per over across the various innings, but control it by the first wicket partnership, which means assume that in both the innings the first wicket partnership is more or less equal, then do the comparison. Or probably you can take, instead of based on the innings, let's look at it based on home or away. So I want to really check out the runs per over based on home or away, controlled by the first wicket partnership. So assuming that across all the groups, the first wicket partnership is more or less uniform. Now we may see that the first wicket partnership may be different in the home games versus the away games, and because of that the run per over may be different across. So I want to remove the impact of the first wicket partnership and then look out for the difference in the means between the home and away games, adjusting for the first wicket partnership. That is what we are doing as a part of ANOVA analysis. So just proceeding with the mechanism, I require the dependent variable as a scale variable, whereas the predictor variables at least one factor to start with, because I will be looking at the uniformity of this particular scale variable across the various values of this factor, but my control variables could be one or more scale variables. So in our example, let's start off with the mechanism. So in our data example, I will look out for analyze, general linear model, univariate, and in this I can probably reset all these things. Then I'll go for runs per over as the dependent variable, and as I said, one factor variable. So we wanted to see it based on home versus away. So I'm taking the home game as the fixed factor, and at the same time I would like to control it based on the first wicket partnership, the runs where the first wicket has typically fallen. So using this I want to do the controlling part. So initially I will get into the model, wherein I'll create my own custom model where I'm looking at these two things as main effects. I want to look at the effect of both home game as well as first wicket partnership interaction. So each of them I want to look at in isolation, how much they are impacting my runs per over. Along with that, I would also select these two and go with the interaction between the two also. As a combination, how much is the first wicket partnership getting impacted? Because of the combination of both the in home game first wicket partnership versus away games first wicket partnership, to what extent is it influencing the total runs per over. So once I do this, probably I want to quickly check out whether the interaction is having any kind of an effect or not. So for that, what I could very well do is I'll go for the options and I'll see the estimate of the effect size. If that effect is much more, then probably I'll continue with it. Otherwise, I can remove the interaction and I can go ahead with my only the main effects to see how each of these independent variable is having any kind of influence on the runs per over. Okay, when we do this, okay, what it is saying is the home games there are 472, home game no there are 472, and home game yes there are 180 records. Okay, both of them are decently large enough, fair enough. Now what we should see is look out for the interaction one. What we are seeing is the significance level for the interaction. So couple of things that we need to look out for here. For the interaction between the covariate as well as the factor, you look out for the significance level. In this case, we got that to be around 0.294, which is greater than 0.05. So you could very well say that the interaction is not so important. So in this case, the interaction between the first wicket partnership and the home or away game is not playing any kind of a significant influence, so we can very well ignore it as a part of our further analysis. So that actually gives me something to remove that and then get into our ANOVA process. But even if we see the other way also, look out for the partial eta squared, which actually talks about the proportion of influence or the level of influence each term is having on the dependent variable. To what extent each of these terms in isolation is able to explain the variance in the dependent variable. What we could see is for the interaction it's almost close to zero, so a negligible amount is being contributed by the interaction, so we can very well eliminate it. And there is a possibility that you can very well assume the homogeneity of the homogeneity across the various innings, or sorry, home and away games, homogeneity in the variant across the home and away game. And what we are seeing is the first wicket partnership is playing a significant contribution to the runs per over compared to any other elements. But yes, we can move forward, wherein we can remove the interaction part at least right now. The same univariate, I am recalling it, and now I don't need the interaction part, so probably I can go with the full factorial model, which actually talks about it doesn't get into the interactions part and all. It only builds the full factorial part for it, and at the same time I can get into the options and probably select all of them, because this will help me in doing. Now I can get into a full-fledged analysis of covariance. So I will even check out for this parameter estimate to see whether there is any kind of difference what is the proportion, what is the amount of contribution each of the variables is really doing to our what is the amount of influence each of the variables is doing to our runs per over. So going with this, I can continue and I can do an OK right now. And so what we can typically see here, now look at the analysis part. Okay, the home games, the mean runs per over, oh sorry, home game no, means in away games the mean runs per over is 7.57, whereas in home games it is around 7.69. We are observing some small difference in the mean runs per over across these two groups, right? and at the same time standard deviation also. In the home game, the standard deviation is slightly more compared to that of the away games, but we may have to check out looking at the Levin's test, which we have discussed earlier also. As per the Levin's test, it is primarily testing out for the homogeneity of the variances across the various groups. So in this case, the Levin's test is giving me a significance level of 0.128, which is greater than 0.05. So I can very well go ahead with the assumption that the variances are uniform across the groups. Variances are uniform across the groups, which we need to, which we can very well give a kind of a pointer to us, saying that ANOVA analysis can more or less be applied in this case. The same we can visualize using your spread versus level plot also, but you hardly we see only two entries going as a part of the spread versus level plot. So probably it may not be a sufficient amount of values to really interpret, because only two values, level means, level standard deviation. But one thing what we could see is as the mean is increasing, probably the standard deviation is increasing. But because only two different values are associated, I don't rely too much even if a difference comes out. So as a basic assumption, I'll typically go with the uniformity across in the variances across the various groups itself. Now, look out for the test between the subjects in isolation. The home game, home versus away, is having a significance level of greater than 0.05, almost zero point 0.4 is having, which means the home versus away in isolation is not having any kind of significant influence on the runs per over, whereas the first wicket partnership is having a significant influence on the runs per over. The home versus away games looks like there is not much of a significant influence on the runs per over. Even the same can be interpreted from the partial eta squared, whose value is very much close to 0. So where we can very well say that the home games, the home or away, really doesn't have much of an influence on the runs per over. That is one conclusion that we can draw. And one way we could look at, if at all we have to talk about it, what we could see is based on the parameters. For the home game equal to no, home game equal to no, we are having a coefficient of minus 0.108, which means when there are two different matches where the first wicket partnership is more or less the same, first wicket partnership is more or less the same, what we are seeing is in the home game, in the away games, the runs per over is around 0.108 less than compared to the same home game. In the away game, we are seeing that the runs per over is almost 0.108 lesser compared to the equivalent home game. But that cannot be made with a lot of confidence, because the significance level is greater than 0.05, and the 95% confidence level also is being mentioned as minus 0.361 to plus 0.144. So which means there is a possibility that the difference between the runs per over in the home and average could be below or even above. That is one of the prime reasons we don't have the sufficient evidence to conclude that the home games runs per over is more than the away games runs per over, provided the first wicket partnership is the same across both the groups. So that is how we typically use the ANOVA analysis for the interpretation purposes. So we are controlling based on one or more of the scale variables, looking at the influence of the influence of the independent factors on the dependent variable. I hope this clarifies the scenario of ANOVA, the concept behind it, the place where you typically use it, and how you interpret the results which are given by SPSS. If you have any further queries regarding the same, you can very well get back to me by giving me a call on the number given below, or you can very well send an email to me at vamsidhar@pacegurus.com. I can very well clarify your doubts. Thanks a lot for listening to this session. Thank you very much.